11.2 is solving systems again, but it's using algebra instead of graphing. So on the substitution, there's three different ways we can solve systems. We can graph them, we can solve them through substitution, and we can solve them through elimination. And so elimination is 11.3 and substitution is 11.2. We're going to ask you to specifically solve them in those methods on the final, and then if you don't, they won't give you credit. They won't give you full credit for solving it a different way. Also on my quiz, I also put on there that you need to solve them using those specific methods. And so substitution just takes a little while to get the hang of. I would grab a piece of paper and follow notes with me, and then as I do some, maybe try to pause it and try to do it on your own after you get the hang of it. And so let's take this first one. Let me see if I can write it like this. I have y equals 2x as an equation, and I have y equals x plus 5. So in the last section you learned how to graph those and find out where they intersect, or if they even intersect. On this one, it's all about using their algebra skills. And so what you want to do is solve one of them for a variable. Now both of these are solved for y, and so you get to choose which one you want to replace. Let me color code a few things. So if I take the second equation, and the second equation is y equals x plus 5. And if I, instead of leaving it as y, if I replace it with the purple 2x, since y equals 2x, then I should be able to replace the y with the 2x. So I'm going to replace it with the 2x. So what I'm doing is I'm combining both of these equations and trying to write a new equation with only one variable. So here's my new equation, and now it only has one variable. I'm able to solve it. The reason we're able to mix these like this is because if they truly are a solution, if I'm looking for that point where they do cross, then their x's and y's are exactly the same in that point. And so that's what allows me to take the y off of one equation and substitute it into the y on the other equation. So that's why it's called substitution. So I took this and I put it right here into the second equation. When I did that, this is what it looked like. So now I'm going to go ahead and solve it. I'm going to pull my x's over into one side, and I get x equals 5. Well, if x equals 5, I now know that on my xy coordinate that they have to share a 5. But I need that y. So what I do with that y is I substitute it into one of those equations. It doesn't matter which equation you use. I usually use the bottom one, but it doesn't really matter. I'm going to substitute it into the top one though. So I can usually try to use the other equation, but it shouldn't matter. So I can take the y equals 2x, and instead of an x, I can put that 5 in there, and I can solve. That allows me to get rid of that second variable, so I'm only solving for y, and I get 10. So then I know that my ordered pair is 5, 10. Okay, that means if I was to graph it, go over 5 and up 10, that is the point that in which these two equations crisscross. And if that's true, and I know that I did it right, or maybe if I didn't know I did it right, I can plug it back in and it should work for both equations, just like you learned in 11.1. So let me do that on this next page. So now I can check my answer. If I think that the point that they crisscross is 5, 10, then I should be able to replace the 5 and the 10 into each equation. So I'm going to do it into the first one. This is my x and my y. So 10 equals 2 times 5. And I just make sure that it makes it true. And it does. So I know that 5, 10 is a point on this line if I graphed it. Now I got to make sure it's on this line if I graph it. So I do the same thing. I replace the 5 and 10, or I replace the x and y with the 5 and 10. And that also makes a true statement. So I know for sure that the solution to the systems of equation is the point 510. So think back to what we just did. So think about the process that we went through. We took two equations. We took one of them and substituted it into the other equation so that we were solving for only one variable instead of two. We found the answer to that variable, then resubstituted that in back to one of the original equations. So let's try another one. If you understand this, you can pause it and see if you can get it on your own. Okay, so here's two new equations. They're both solved for y, so I don't have to worry about solving. And not all of them are going to be solved for y, and we'll approach those. So I'm going to go ahead and take this x plus 3 and slide it in where that y is. So I get, this is the original, and I'm going to replace the y with the x plus 3. Remember, on these substitutions you also have to show work. If you don't show work, we won't give you credit because we need to know that you were using that specific method. I'm going to take all my x's over to one side. That leaves me with 3 on the left and x plus 5 on the right. Take my 5 and move it over, and it leaves me with x equals negative 2. I'm going to go ahead and put my negative 2 up here so I don't forget. This is where my answer goes. So now I'm going to substitute in the negative 2 for one of the x's in one of the equations. It doesn't matter which. I'm going to go ahead and use the bottom one. So y equals 2 times negative 2 plus 5. That's y equals negative 4 plus 5. So that means y equals 1. So I can check it. Is negative 2 plus 3 going to give me 1? Yes. And is negative 2 times 2 going to give me negative 4 plus 5 is 1. So they both check. So here's another one to try. So you might want to pause this, try it on your own, and then come back and see if you did okay. Remember, it doesn't matter which one you substitute in. So I could substitute this 3x into this y, or I can substitute this x minus 2 into this y. It doesn't matter. And so if you do it a different way and then you play this, you might want to play until the end and just see if you had it right. Okay, so I'm going to go ahead and substitute this 3x into this y. So that's going to make 3x equals x minus 2. I'm going to pull my x's over. 2x equals negative 2. X equals negative 1. So I know that negative 1 is my x. This is where I'm going to put my answer. I'm going to resubstitute back in. I'm going to go ahead and put it in the bottom one. So negative 1 take away 2 equals negative 3. So I get negative 3. And then I can double check it. Remember, you can, oops, there. Always put it in an order pair, but always remember you can double check them by plugging them back into the original equation. Okay, so the original equation right here, if I erase this y and I put a negative 3 and I erase this x and I put a negative 1, does that make that statement true, that equation true? And yes, it does, so I know it worked. And then I can do the same thing with the second equation. Remember, it has to work for both equations in order to be a solution. The more you do of these, the easier to become. I would say before you even do your assignment, try to run yourself through these, see if you can do them on your own. And then pick some out in the book that are that have some answers in the back, or you'll know if you got it right because you can plug them back in. But pick some out. The second half of the final is all about substitution, graphing systems using substitution and using elimination. And so it's a huge part of the final. So here's one where neither one of them are solved for y. So the first thing you want to do is you want to change them to solve for one of the variables. Okay, it doesn't always have to be y. So if you notice that this one right here is already solved for x. So that means we can just replace it where the x is. It doesn't always have to be y. Usually I always do y just out of habit, but you don't have to. So I can replace that x with 2y minus 4. And then I'm going to write the rest of the equation in there. So all I did was put the red 2y minus 4 where the purple x was. So now I don't have any x's in my equation, I have only y's. So I'm going to combine like terms. And I'm going to bring my 4 over. And divide by 10. And I get y equals 2. And so now I'm going to substitute it back into one of the equations. It doesn't matter which one. I'm going to go ahead and do it in the top one. So that it's easier. So I get x equals 4 minus 4. And so I get x equals 0. So I think my ordered pairs are 0, 2, because remember it goes x and then y. And then again, if I'm not sure if it's right, I can plug them back into the original problem. So the original problem was x equals 2y minus 4. So I can put a 0 in for x and a 2 in for y. And I can see that that is 0 equals 0. I can go to my other equation, because remember it has to work for both. And I can take that equation and plug in the 0 and the 2 and see that that one also works. So then I know that that has to be the answer. It's a guarantee. So you don't have to wonder if you're right or wrong. So here's one you can try. Maybe try solving for x. You don't have to on this one, but just so you get the hang of it. Usually I'll just look to whatever's easiest to solve for. Like on this one, I would probably look at the 2 and think about what would you solve for, which one would you solve before you started the problem, which one would you isolate. So I would probably choose this second one, and I would just choose x or y. Usually I choose y just out of habit, but let's do x just so that you can see how that works. So you might want to pause this and then continue. So I'm going to take this equation and I'm going to solve it for x. So that means I have negative y minus 7. Okay, so I'm going to take this and I'm going to put it in where the x is in the second equation. Now one thing on this kind of problem that you're going to have to be careful of, and this happens a lot, not just because I solve for x, just because it's the nature of the problem. When I put that in, that black part, let me color code it. When I put that black part in for x, I need to remember that it is sitting next to that 2, which means times 2. So I can't just write minus y minus 7. I have to write times quantity negative y minus 7. And I'm going to have to use some distributive property. Guarantee they'll have problems like this on the test, and I will have them on the quiz too, where they're testing to see if you know that if you insert that in and there's already a coefficient there, that you then have to use your distributive property. So that's negative 2y minus 14 plus y equals negative 4. Combine my y's. Pull my 14 over. Take care of my sick husband. It's okay. And I get y equals negative 10. And then I'm going to plug back in. I'm going to go ahead and plug it into the lower equation because it looks like it'll be easier. So I get x plus negative 10 equals negative 7. I'm going to add 10 to both sides. and I get x equals 3. And then I'm going to write it as an ordered pair. Don't forget, they dock you if you don't. And then I can plug those in and try those again. So here's one that you can try. So here's one that I want you to give that a shot on. Why don't we solve for y and plug into the second equation. So solve for y on the top equation because that looks like it'll be easy. Okay, so you go ahead and do it, pause it, and then come back and see if you were okay. So I'm going to solve for y on this one. So that means my x is going to move over. I'm going to have to add x to each side, which makes it a positive x plus 4. I'm going to take this and put it right into the y. So I'm going to get 3x minus 2 times the quantity, x plus 4, equals negative 7. So I'm going to have to use the distributive property. But on this one, what's tricky about that is that I got to remember that it's a negative 2 that's being distributed through. So make sure you pay attention to that. So 3x minus 2x minus 8 equals negative 7. A lot of places that if you don't pay attention to your algebra and signs, you can really screw up. And if you screw up early on, it messes up the whole problem. But on the final, they'll look to see, if you messed up, they'll look to see where the mistake was, and then they'll look to see if you had the rest of it right, if you wouldn't have made that mistake. And so you want to make sure that even if you try to plug it back in and you know the answers are wrong, if you can't figure it out, leave your work there. So add 8 to both sides, and x equals 1. Plug it back in. I'm going to put it in the top equation. And I get y equals 5. So I have the ordered pair 1, 5. Now remember, I would be checking each one of these. I'm not, because it would make the video so long, but if I was you, I would be checking, plugging them back in so you get the habit of that, and it just improves your skills too. So here's another one you can try. Okay, so here's one. This one's already solved for y up here, so I'm going to go ahead and plug it into y to save me some time. So I didn't color code this one, but this part right here is where I plugged it in here. So now x, negative x and positive x, these will cancel out and the x's are gone, and I'll get negative 4 equals 3. Well, negative 4 can't equal 3, so this is a no solution. Remember, you can have no solutions in here and you can have infinitely many's in here. No solution means that there's no way that that's ever going to work for both equations. Okay, so here's a story problem, and there will be story problem on the quiz, and there guarantee there will be on the final. So the sum of two numbers is 50. The first number is 43 less than twice the second number. Find the two numbers. They're going to ask that you write it in, that you write a, that use a system of equations and that you write your equations. If you don't write your equations and you just guess and check it, they're not going to give you full point. I'm not sure how many points they would give you, but it will be docked quite a bit, at least half. So you want to make sure that you write your equations. So the first thing I'm going to do is I'm just going to pick an x and a y to represent it. So this is, x is going to be my first number, and y is going to be my second number. Okay, so if I look through this first sentence, the sum of the two numbers is 50. So sum indicates addition, so I should be able to say x plus y equals 50. Okay, then if I take a look at the second part, it says the first number is 43 less than twice the second. So the first number, which was x, is, and is equals, and I'm just following the sentence, the first number is 43 less than twice the second. So 2 times the second, and then take away 43. Now you have your two equations. Now you can use substitution. Since it's already solved for x on the bottom one, I'm going to go ahead and use that. But again, you can solve for y or do it a different way. Especially when you're looking at my answer keys. I wrote on the top of them, you know, on the top of the worksheet ones, that you can solve different ways. You don't have to do it. Sometimes I solve for x, sometimes y. I get lazy and I just do whichever one looks easier. Okay, so that's going to be 3y minus 43 equals 50. Add 43 to both sides. Divide by 3, and I get y equals 31. So I know that the second number is 31. And now I can plug it back in, so I'm just going to go ahead and use the top one. 31 plus something equals 50. Take 31 over, and y equals 9, or x equals, whoops, I solved for y. Let me redo that. It's like I already have y. X plus 31 equals 50. And I know x is 19. So then I just need to make sure that I answer the question that the first number is 19 and the second number is 31. Okay. Look for those story problems. I'll try to add one to each video, and then make sure you practice them. I'll try one more. Okay, so if I buy 2 books in a backpack for a total of $26, and each book costs $8 less than the backpack, can you write 2 equations and solve that system to find out how much a backpack was and how much a book was? Remember, the guess and check, I could sit there and guess and check and probably get there faster. That's not what this is about, though. This is about, can you write that systems of equations and solve it within that strategy? And so they're going to be looking for that specifically. So I'm going to go ahead and name my X as my books. And it doesn't matter if you go, well, X is your books or Y is your books, because in the end, you're going to have the same answer. You're going to figure out what X is and how much Y is, and then they're going to relate to a book or backpack, whichever you made them. So don't worry about, well, how do I know which one to call X and which one to call Y? So now I'm going to write my 2 equations. So I'm going to look at the first sentence. I bought 2 books and a backpack for a total of 26. So that's X plus Y equals 26. You'll get a lot better at these a lot faster. They'll become easy. Each book costs $8 less than the backpack. So the book equals the backpack take away 8. So now I have my 2 equations. I'm going to take my X and plug it in. So I have Y minus 8 plus Y equals 26. That's 2Y minus 8 equals 26. Take my 8 over, and 2Y equals 8. 34, and Y equals 15, 16, 17. So, oops. What did I do? Oops, I just realized that I didn't do 2 books and a backpack for 26. So this should be a 2 right here. Sorry about that. Let me go back. It's like, that doesn't make sense. This is what happens when stuff doesn't make sense. You can go back and find your error. Okay, so 2, and this will give you some practice at that distributive property. Remember, the reason I need these parentheses here is because I'm sliding a quantity in here next to the 2, and it's 2 times the whole thing. Otherwise, it would just say 2 times y minus 8, but we want it 2 times the whole thing, y minus 8. Guarantee they're going to have those on the test. Okay, so 2y minus 16 plus y. That looks better. So that's 3y minus 16 equals 26. Bring that 16 over, and I'm going to get 3y equals 41. 2, and then divide by 3, I'm going to get y equals 14. So then 14, I can plug the 14 back into here. X equals 14, take away 8, so x equals 6. So then make sure that you finalize it by saying, you know, your backpack, you named your backpack as the Y, so your backpack is 14 bucks, make sure you label, and your books are $6 each. Okay, so that's the chapter, or that section. Let me know if you need more story problems to practice on.